All right, guys. Hey, we're going to jump into, I guess today we're going to jump into function families day one. Okay. I know it says day one, which means your next class is probably going to be function families. Oh, you guys are so smart. That's good. Okay. Yeah, function families day two. But today we are going to cover so much information. There's going to be, oh my gosh. I mean, there's going to be so much that you need to cover, that I need to cover. And it's just a lot of information. Now, one thing I'm going to show you guys is this right here, and you're going to hear this from me more than once, okay? This is basically what Algebra 1 is. What am I drawing? Yeah, I'm drawing stairs. Right, where are we right now? We're basically right here. You guys with me? Where do we want to get? We got to get to the top of the stairs. Now, here's the difference in our class compared to other classes. Okay, here's the difference, and I've said this more than once, and this is the way that it works, okay? If we are going to keep doing the staircase and getting up to the top, when we're doing Algebra 1, you can't just forget what's at the bottom of the stairs and just leave it alone and then move on, okay? It's like other classes, maybe like history or science or whatever. A lot of classes you can do a unit and then go to jump to another unit and forget what's going on. You can't do that in algebra. The stuff that we're going to cover today, is stuff that you need to remember. We need to remember what a function is, what an input, what an output, what a domain and range, and all that other stuff is, because you're going to hear that from me more than once. So it all just kind of works together. So like if I'm here, I might still be talking about stuff at the bottom of the stairs to get to the middle. When I get to the top of the stairs, I promise you, I'm still going to be talking about the stuff that we're doing today. When we get to quadratics, I promise you some of the stuff you're going to see today, we're going to talk about quadratics. You're going to see it today, but we're going to staircase on it. We're going to start very, very minimal, but as we progress throughout the year, it's gradually going to staircase up, but you cannot forget the stuff at the bottom of the stairs to get you to the top of the stairs. Does that make sense? You have to continue to use that staircase. This stuff is always going to matter the entire year. This will not. Okay. Well, I say this will not. It's not going to be by itself. Fair? Okay. All right. So here we go. Function families is day one. Now, a lot of this stuff that we're going to cover, there's not a whole lot of notes. There's not a whole lot of notes to talk about this, but here we go. A relation can be represented in the following way. Now, here we go. Ordered pairs, and I want you to write this down below it. Ordered pairs are listed as XY. They're all listed as XY. They're all listed as XY, okay? So this one's XY, this one's XY, this one's XY, this one, and so on, okay? Now, let me go ahead and talk about my XY table, because you're going to hear me say XY in a number of different ways. I'm going to use a bunch of different words. So let me go ahead and talk about those words. Yes? All right, here we go. Write this down. This is extremely important. XY. When I'm talking about X and Y, does anybody, well, we'll talk about it in a minute. This is going to be my input. The X is my input. What is the Y? What? My output. In other words, whatever I put as my input is going to change my output. Would you agree? Think about it like this. If I have Y equals X plus 2, okay? Well, if I put a 5 in here for X, what's 5 plus 2? Won't that give me a 7? Yes? Input, output. When I put a number in, it changes what goes out. Okay? If I want to change my diet, it's going to change my output. That's just the way life is. Anything you put into something is what you're going to get out of it. You ever hear parents say that? Hey, you're going to get what you put into it. Your coaches, you're going to get out of it what you put into it. Okay? Same thing. Input, output. Okay? All right, here we go. Another word. Domain and, what's the other word for domain? And range. The domain is the X. The range is the Y. Domain is X. The range is the Y. Domain is X. Range is Y. So if you hear me say input, output, domain, range, I'm still talking about XY. That does not change the definition. It does not change the information. Okay, everybody good? Last one. What did we do the last class period? What was the topic? Say that again. Independent and dependent. So here we go. Which one is which? Do you guys remember? Yeah, that's right, guys. Here we go. Independent. What does independent mean? Yeah. If you're an independent person, what did I tell you? You're independent because you can do what you want, right? You can do whatever you want. Okay. Dependent means that you're relying on something else. Okay. This answer relies on what I put into the problem. It relies on that. I can change what I put in for X, but the result is always going to be that second number. I can change X. I can't change Y. Okay. Unless it's like a specific problem. In general, we're talking about X is then Y. Okay. Is everybody good? All of this stuff is going to tie together. I promise you, this is all going to tie together. We're going to talk about so many different things today. This is going to be a little bit longer of a lesson. I apologize, okay? But it's a lot of information, okay? The practice won't be terribly difficult, but there's a ton of information today, okay? So you've really got to stick with this, okay? All right, here we go. So we talk about equations, okay? X goes to Y. The Y changes, okay? Now we'll get to that. I was about to say something else. Moving on. Verbal. I know it's hard to read because I had to zoom it. When I was creating this slideshow, I zoomed to try to make it so you could read it. It says the relationship between students in your school and students' birthdays. It's a relation, okay? Basically how they cooperate with each other. That's a relation. Now, put a star next to this one. This one's called mapping. This is mapping. This is called mapping. You are going to see this later on. You are going to see this. You're going to see this on the STAR test. It is going to be there. Guaranteed. This should be an easy one. Now, basically what this means is that 1 goes to 2. In other words, that coordinate is 1, 2. This is my X. This is my Y. My input to my what? Output. It all ties together, okay? So this is 1 to 2. This means 4 to 5, and it also means what? 4 to what? What's the second number it gives me? It gives me this one, and then it also gives me this one. 4 to -5. So let me ask you this. If I ask you to solve the problem 5 plus 3, what is 5 plus 3, guys? 8. Let me ask you again. What is 5 plus 3? Okay. You gave me the same answer twice, which both of them are correct. But let me ask you this. If I ask you what 5 plus 3 is, and the third time or the second time you said 7, in your mind, would you realize if somebody said that, you would be like, hey, you're wrong. Does that make sense? Here's the deal. I cannot get two different answers for one output, or for one input. I'm sorry. One input should only get one output. Okay, well, that's going to be a definition here in a minute, but just stick with me. Has anybody in middle school or whenever worked a problem and your teacher's like, go back and try this again, and you got a different answer? You don't know what you did different, but you got a different answer, and you're like, what in the world did I do? Has that happened to anybody? I see some hands going up. Yes. You realize that you did something what? How did you know that? How did you know it was wrong? Because you got a different answer the second time you did it. When you do the same problem and you get a second answer, something's not right. Think of it this way, 1 to 1. If I go down to the soda machine and I scan now I was about to say dollar. They're not dollars. Now everybody has those cards that you scan. So I scan my Apple Pay, boop, and I push a button. I push Dr. Pepper, and 2 or 3 of them fall out. First of all, that's terrific. Everybody wants extra Dr. Pepper. Yes? Like you're like, hey, bonus, okay? It's like Christmas, okay? But the deal is, when I scan it one time, what should I get? 1 to 1. If I get 2, that's terrific sometimes, but that's not functioning. Okay, I've always used the example of like relationships, 1 to 1. Okay, you throw a third person into a relationship and the other person doesn't know about it, it's probably not going to function very well. Okay, so you want to make sure 1 to 1. One input, one output. That's the way life works. Okay, 1 to 1. So every input should only have what? One output. So this one is actually okay. How many lines are coming off of this? 1. That's okay. How many lines are coming off of this? 1. That's fine. How many are coming off of this? That makes it not a function. That makes it not a function. All you need, I don't care what's over here. I do not care what's on this side. I don't care. All I care about is this side. 1, 2. What this tells me it's not a function. If this was 1, 1, 1, 1, 1, 1, I'm good. I don't care what's over here. This doesn't matter. I just need to see 1, 1, 1. Is that fair? So let me ask you this. Based on what I just told you, tell me if this is a function. 1, 2, 3, 4, 5. Function or not a function? Hold on. How many lines are coming off of each one? 1. 1, 1, 1, 1. Okay, how many different ways can... Hold on, what's 5 plus 3? What's 1 plus 7? What's 9 minus 1? You got the same answer 3 different times. Does that make any of those problems wrong? No, I can get the same answers. I can't get 2 different answers if I have 1 input. I can't get 2 different answers if I have 1 input. Is everybody, you stuck with me on this? That's okay. This is actually okay. This is okay. This is okay. This is okay. But what if I have this? Now I've got 2 different outputs for 1 input. That's not good. Okay, is this sticking with you? 1, 1, 1, 1. That's okay. Then we're Gucci. Okay, we're good. Gucci. I don't know what that means. It's something I picked up on the internet. All right, here we go. Very good. All right, here we go. This is called a parabola. We will get to that later. I'm going to hold off on that for right now. Okay, and then we're going to talk about this. Okay, domain and range. Now, this is obviously we know this is a table, right? Yes. X, Y, X, Y. Domain, range. You don't have to write all that down, but also I could change this into mapping. I could go -1 goes to what? What's -1 go to? +1. Boom. And it's on the other side. It all works together. It really, really all works together. It 100% does. Okay? 2 to 0, 5 to -5, 6 to -5. That's okay because 5 only has that one. 6 goes to this, 7 goes to that. It's okay that these match. That's 100% okay. That's fine. All right? Now, here's how this one's different on the mapping, by the way. What is that number? 5. What does it go to? Okay, so let's do 5 to -5. Let me show you how this works. 5 to -5. Okay, we're good there. What does this go to? 6 to -5. Don't put another -5 over there. You only write it one time and it goes to the second. But that's okay. I'm still 1 and 1. I'm still okay. That's still fine. 100% okay. Is everybody catching on? Everybody's catching on, right? Stick with me. I see some people starting to wander a little bit. If you need to stand up and stretch, stand up and stretch. Do that. Okay? I do it in our staff meetings. I promise you. I get tired. I need to stand up and stretch. Stand up and stretch if you need to. I'm not going to get mad because why are you standing up? Okay? Stand up. All right, here we go. All right, here we go. This is extra. I'm going to slow down because you need to hear this. Write this down. Vertical line test. And I mean put a star next to that. Vertical line test. Put that somewhere on your notes. Who knows what a vertical line test is? Well, it's okay, it's that. Okay, what does that mean? Okay, so here's the deal. Now, I love when I watch you guys test and I see like pencils or pens or whatever, and they take these pencils or whatever and they slide it across computer screens. I know exactly what you're doing. It's called the vertical line test. And what they're going to do is they're going to ask you what a function is. And I'm going to ask you today what a function is, okay? A vertical line test is when you take a, what kind of line? Vertical. Vertical, I grabbed this because it's nice and big. Okay, vertical line. And I'm just going to keep it vertical, and I'm going to slide it from either left to right or right to left. It doesn't really matter. And I'm going to slide it across the graph. And if it touches anywhere on the graphed line more than once, it is not a function. Okay, hear me on this. It is not a function. Okay, is everybody okay with this so far? What I mean by that, if I go across this graph, this parabola that they have, the line that they drew was right there. Why is it a function? Because the only place it touches it is right there. That's good. That's fine. That's 100% okay. Yes? This one is a problem because if I drew the vertical line and I slid it across, it would stop right here and it touches twice. It's not like, oh, well, if I put it right here, it's only once. Okay, it's not where you put it. It's can you touch it more than once? You slide it all the way across the graph. If it touches more than once, then it's not a function. Okay? And here's where it all ties together. So stick with me on this. Stick with me. Watch this. If I make these coordinates, please just check this out. I want to show you why this doesn't work. Is everybody watching? I'm going to put like a little coordinate plane. So let's call this 1, 2, 3. So let's call this point right here 3, -2, because we went down 2, yes? And let's call this point 3, +2. What just happened? 3, negative 2, and 3, positive 2. What just happened? My one input. What is my one input? What's my 1x number? My 1x is 3. A 3 and a 3. What can you tell me about both the outputs? They're different. My one input has 2 different outputs. That does not work. So if I do the mapping, it would actually look like this. Didn't I tell you that you can't do that? You cannot do that. You cannot have the same input. So if 2 points are above each other, it will not work. It will not work ever. Okay? You guys with me on that? Okay. We'll talk more about that here. I'll show you an easy way to know if that works or not. Okay, I'll show you that here in a minute. Okay. Lots of information. Oh, I just spit everywhere. That was weird. Okay, is everybody okay? You guys are in the splash zone on the front row, by the way. So I'm just letting you know. All right. Very important. We're at the bottom of the worksheet, yes? All right. This is very, very wordy. Somebody read that to me. Somebody read it. Go ahead. Yeah, okay, so that's kind of wordy. Would you agree? So you want me to shorten that up for you? You going to make this a little bit easier? What's another word for domain? No, range is down here. X or, let's say, I heard it in input, okay? So here's what it's basically saying. Input, what's another word for range? Output, right? Let's stick with input and output. Here's the short version. Hold up. A function is a relation that assigns each element of a domain to one element of the range. What that simply means is that every input, and please write this down, I'm going to put it on the board. Every input can only have what? Write that down. Every input can only have one output. Every input can only have, I'm going to say that more than, I'm going to say that so much. Every input can only have one output, guys. 1 to 1. If it's anything other than that, it's not a function. Anything other than that, it is not a what? Not a function. What's the rule? Say it again. Every input can only have one output. You need to ingrain that into your brain. Hey, that rhymed. That worked out well. I'm a poet and I didn't even know I was. Okay. All right. Is that how it goes? All right, going on. So here we go. The x values do not repeat. Here's a dead giveaway. If you look at all the x's and none of them repeat, it's 100% function. 100%. Let me show you. Let me go back. Do any of these x's repeat? Function. I don't care what's over here. I do not care. If these don't repeat, I'm good. Okay? If the x's do not repeat, that is good. Okay? Is it good if the x's do not repeat? Yes, 100% okay. When we list the points, if the x's don't repeat, you don't even need to look at the y's. We're good. We're definitely good. And here we go. Vertical line test we've already talked about. Okay. Last part of the slide, and then we're going to go to our worksheet. Okay, cool? Is everybody still with me? 1 to 5, show me that you're still with me. 1 means you're like, yeah, 1 to 5, show me. 1, you're not there. 5, you're like, I'm still with you, coach. I see some 4s. Okay, fair. Hey, I'll take it. It's more than a 2 or a 3. I'll take that. Good, here we go. Which one is not a function? All right, let's start with the first one. With your table partner, tell me, is it a function or not a function? Just take a look at it. Talk to your neighbor. Be able to tell me why here in a second. Okay, hold on. First one, function, not a function. Why? The x values repeat. Now, hold on. Can the x values repeat if the y also repeats? Hold on. What's 5 plus 3? What's 5 plus 3? Is it okay to get the same output twice? Does it make one of them wrong? Is one of those problems wrong? I got the same, I gave you the same inputs, and you gave me the same what? Does it make one of them wrong? Okay, that's the only time x can repeat. is if you have the same output. But I don't think I've ever seen a problem where the x is repeated and they gave you the same output. I don't think I've ever seen it. I'm just telling you that would make it actually okay. That would actually be okay. That would be 100% fine. Okay, but this one, 0 to 0, and also 0 to what? That one's not good. That one makes it not a function. That one's not good. Okay, here we go. D, function, not a function. Okay, hold on. How many lines? How many lines? How many lines? 1. How many lines? 1. How many lines? What's this one got? Not good. Not a function. Just like that. Did I even say, you know what? I didn't even look at the right side. I don't even know what numbers are on the right now. I really don't know. I was looking at the left side this whole time. I do not care what's on the right side. I don't care. 1, 1, 1, 1. That is a function. You don't even need to worry about the other side. Good? All right, here we go. So that one's not a function. This one's not a function. What about this one? Function, not a function. Hold on, what are my x numbers? -7. What else? -5, 2, and 3. Do any of the x's repeat? Function. Function. We're good. As long as the x's don't repeat, we are good. What's the word? We're Gucci, I guess. Okay. Yeah, I don't. What? You're good. All right, so here we go. Vertical line test. If you get a graph, easiest way, vertical line test. Just slide it across. Is there anywhere that it would touch that graph line more than once? No. So what is that good or bad? That's good. That's a function. That passes the vertical line test. We are good. Okay. Are we good? Cool. Let's go to the second worksheet. Bang. All right, here we go. Let me get my coffee. Happy juice. All right. All right, we good? Now we're going to talk about the different types of graphs, okay? Okay, hold on, let me stop. Okay. Once again, 1 to 5, show me how you feel about function, not a function. Go. 1 to 5, show me how you feel about function, not function. I see a lot of 4s, some 5s. That's good. That's telling. Okay, if you're at a 2, I literally had somebody last hour show me a 1. If you're a 1, tell me you're a 1. That way I can kind of keep an eye on you and help you out, okay? So you're good, no worries. So everybody's a 4 or 5. That means I did a terrific job teaching. Okay, all right, moving on. I'm kidding, kind of. All right, here we go, guys. Now we're going to tie it all in together, yes? So I'm going to do this first one with you. I'm going to do the first one with you. Here's my set of points. Now, sometimes they're going to give you a table, and you got to do the ordered pairs, the mapping, and all that stuff. But on this one, they gave me the points, so I'm going to set up the table, and I'm going to set everything up. Dude, you are chewing them chips loud. Okay, you're going to... Can you guys hear them chewing those chips? Okay. Yeah. All right, here we go. I'm not calling you out. They don't know who you are. Okay, here we go. So table. I'm going to make my little XY table, just like this. Make like just big cross is what I call it. Just make a big cross, big T, lowercase t, or whatever you want to call it. Now, what's my first point? -2, -3. There's my first one. XY. Yes? What's my second point? -1, -1. Good. Third one. 0, 1. Fourth one. 1, 3. What's the fifth one? 2, 5. Everybody good so far? All right, here we go. So now we're going to do the mapping. So I'm going to draw my little circles. You can do it. You can do the circles afterwards if you want to. It doesn't really matter. So -2 goes to -3, right? Remember, if the numbers repeat, don't write them more than once. Okay? -1 goes to -1, like that. 0 goes to 1. 1 goes to 3. 2 goes to 5. Now we're talking about mapping. We're seeing how the coordinates match up with the tables, how they match up. Now, first of all, does it look like a function right now? Does everything show you function or not a function? Everything shows you function because 1, 1, 1, 1, 1. None of the x's repeat. Everything feels like it's okay. Yes? Everything feels fine. Okay, so let's move on. Let's graph the points. -2, -3. -2, -3. Left 2, down 3. You guys remember how to graph? First number, if it's negative, you go left, and then the second number is negative, so I went down. left, right, and then up, down. First number is left, right. -1, so I'm going to go which way? Left 1, and then -1, so up or down? Nope, negative. Negative goes down. Look, -1, -1. You're good. That's why we're practicing it. You guys are, we got to get back into stuff you covered in middle school. I get it. All right, 0, 1. There's my y-intercept. Okay, and then we've got 1, 3. So now it's positive. So which way do I go? Right 1, up 3. And then 2, 5. And I draw my line. Well, that was a really bad line, but it's kind of hard to draw on this thing. Sometimes I get a really, really good line. Sometimes it's all over the place. All right, are we good? All right. Do what? Everybody's fine? All right, let's talk about first of all, is it a function? Yes, it's a vertical, it's a straight, hold on. Straight lines are always going to be functions, except for, anybody know? What's the only straight line that is not good? Nope, that one's fine. This one, undefined. We'll get to that later. This is the only straight line, perfectly, like just one straight line. This is the only one that's not good. Why? Because if I draw a line that's vertical, and I put it, and I do this, don't I cross it infinitely? That's not good, okay? And that would be, let's say you do a coordinate. Let's say that's like 3, 4, 3, 3, 3, 2, 3, -1. All these inputs have like all of the different outputs. That's never good, okay? That's why it's vertical, okay? All right, vertical lines, are vertical lines good? Somebody say no. No, they're not good. What are not good? Okay, not functions. All right, here we go. This function family, this is called linear. Linear. Why is it called linear? Because it's a line. Don't overthink it. Don't overthink it. All right. All right, it's linear. So here we go. Your parent is going to be y equals x. Or you could say y equals mx plus b. All right, you guys with me on this? This is your equation that makes linear. Learn that equation. How many of you have heard y equals mx plus b? Everybody, yeah, we'll double hands. Like we're going to hammer that equation into your head by the end of this year. I promise. Okay, you will know that one inside and out. All right, here we go. Tell me about this equation. Tell me, show me about this line. Tell me what you know. Anything. It's a function. That'll work. This is a function. What else? What do you see? It's a graph. 5 dots. Okay, you're fine. Hey, you're thinking. I like it. Keep going. Tell me what you see. Straight. Okay, it's linear. We've already talked about it being linear. That's fine. Which direction is it going? Up. Hold on. How do you know it's going up? Listen to me. How do we know it's not going down? Thank you. Say that again. You always read your graphs from left to right. So this one is increasing. This one's increasing. This one is increasing. You guys with me? Is it constant? Well, this one, well, it's increasing. Okay. Constant would be straight sideways. Okay. Now, 2 more words I want to teach you. Everybody with me? Write these down somewhere. You have discrete and you have continuous. What does continuous sound like? Continuous. Yeah, that's right. Okay. I forgot to do this last year, and I almost forgot to do it during second hour. I want to make sure I cover this. Okay. What does continuous sound like? Goes on like it does like this, right? What can you tell me about the line? Hold on. Is there a line, or do you think it's a bunch of dots? If it's continuous, what do you think it is? Lines. Okay, so here it is. They're connected. They're connected. What do you think discrete is? What's the opposite of what I just showed you? Dots. Okay, make sure you know the difference. Discrete, continuous, okay? So what would this one be? This one would be continuous. Okay, we good? Is everybody okay? All right, so here's what I want to do. Yes, sir. Okay, hang on 1 second, okay? All right, is everybody good so far? So here's what I want you to do with your partner. I want you to go to graph B. And I want you to fill this one out. I'm going to pause the video for those of you that are watching. If you're doing this in the class, you guys can pause it or whatever. Go ahead and work on that one, and I'll come back here in just a second. Go. All right, guys, coming back together. Hey, let's do this. So, hey, what are my ordered pairs, guys? Hey, back together, guys. Back together. Here we go. 0, 1. I like that you're talking. That's good. What's the next one? 1, 2, 2, 4, 3, 8. Everybody good? So if I do the mapping, do any of these numbers repeat? So I would just 0, 1, 2, 3, 1, 2, 4, and 8. Yes? Don't overthink that. Please don't overthink it. If they don't repeat, that makes it very, very easy. Just write them in order and just draw the lines. All right, here we go. 0 to 1. So that would be my first point. There's my y-intercept. Yes? 1 to 2. 1 to 2. 2 to 4. So go over 2, up 4. Well, we're not linear, right? Because what's it doing? It's curving. Now watch this next one. 3 to what? 3 to 8. Oh my gosh. Okay, so we're taking off. Okay, so what function family is that? Do you may know? Okay, this is exponential growth. Exponential. This is exponential, okay? And my parent equation is this right here. Y equals B, and your x is actually going to be your exponent. Your x is the exponent on this one. So as the exponent changes, it shoots up, okay? If I put a third one on there, I believe the next one would be, let's see, 2 to the third. So 2 to the fourth power would be, man, up there. Quite a way, 16. Yeah, 16 and 32. It would be way up. Like it's going to take off on you, okay? So that's exponential growth. So here we go. Tell me what you see. It's continuous. This is continuous. Okay, what else? It's a function. What else? It's increasing. Yes. When you guys take your test, by the way, they're going to give you a graph and there's a whole bunch of options and you got to check the right options. You remember that? Yeah. So you're going to have a whole bunch of boxes and you got to know that it's discrete. You got to know that it's continuous. You got to know that it's increasing. Okay, you got to know what it's doing left to right and stuff. So if you miss one of the boxes, you're going to be wrong. Okay, we give you points for every correct box, okay? So this one is, what did we say, increasing? What else? I think that's about it, okay? There is a thing called a horizontal asymptote. We will get to that later, okay? That's a lot of information. We're going to get to that. It's a fancy word. I'll explain it. That's a whole nother lesson. We will get to that. I don't think asymptote's on the test. Yeah, surely not. Okay. All right, we good? All right, going to letter C. Now they're going to give you the mapping, and you got to do the rest of them, okay? With your partner. With your partner, go ahead and do this one. Ready, go. And we're back. Okay, good. All right, here we go. What are my points? Dude, that chip. Okay, this dude is crunching these chips. Okay, all right. No, all right. No names. No names. Okay, here we go. All right. That's really funny. Okay, here we go. What's my first point, guys? -2, 4. What's after that? -1, 1. 0, 0. 1, 1, 1. 2, 4. Okay, let me ask you this. Based off of what you see here, is this going to be a function or not a function? Function. Why? How many lines? 1, 1, 1. They're all ones. So table X, Y. I'm not, just for the sake of time, I'm not going to go through all these. They all just basically get copied over there. Yes? Everybody good? It's the same thing. Okay? All right, so here we go. Let's do the graph. -2, 4. So -2, +4. So we got a point here. -1, 1. 0, 0. 1, 1. 2, 4. Yes? All right, so I draw my line. It's close enough. Parabola. Okay, it's a parabola. That's called a parabola. We will get to that later. Okay, that's more. This is, anybody know what it is? What is it? Well, it is a function. Okay, well, let's go ahead and put that over here. What's the parent? Anybody know what function family this is? This is quadratic. These are quadratics. In other words, y equals x squared. So now, excuse me, now the exponent is a 2 and not just an x. Okay, so it's always going to be squared. So now we'll get to this later, but quadratics are always going to be a curve. It's either going to be a u or an n, depending on if it's positive or negative. This one's positive, so it's going up. What do you think the negative does? Goes down. You guys are so smart. Okay, good. So positive, negative, right? And we'll get to where we can like squeeze them, vertical compression, vertical stretch, so on. Okay. Again, a lot of information. Okay. So there's quadratics. We're good on that. So tell me what you can see. Function. What else? What do you got? It is continuous. Good. What else? All right, I'm about to mess with you just a little bit. Okay, is it increasing or is it decreasing? What? Say that again. She's right. It's doing both. Hold on. What did you say? We read the equation we read the graph. Which direction? Left to right. So if I start on the farthest left point, okay, think of like a skate park. That's a great one. This is the first time I've thought about this. Okay, skate park. I'm on the top of the ramp. I get to here, right? Here's me, and I'm on a board, and I got my wheels. Okay, so I'm cruising along. Okay, and I get to this point right here. What happens when I get there? I go down, left to right. Once I get to that point, I get to the bottom, what happens? I go back up. So it is increasing. I'm sorry, it's decreasing. And it is also increasing. Does that make sense? It's always left, right. Man, this skateboard thing that's the first time I've ever thought of that. I'm so smart. Okay, good. Yay me. Okay, good. Okay. Hercules. Okay, good. All right, so increasing, decreasing. One more. Does it have this graph right here? Does it have a top? What do the arrows mean? Goes on forever. So is there a top? Is there a bottom? Is there a bottom to this? Yes, there is. This also has a minimum. It has a minimum. There is a bottom to that graph. If it flips over and it goes down, what do you think it has? A maximum. Kind of like a mountain. There is a top to the mountain. Okay, this isn't a mountain. That's a big bowl. Okay, my cereal bowls are stupid big. Okay, good. Everybody good? Am I the only one that eats massive cereal bowls? When I was a kid, I'm not kidding, I grew up eating cereal with those like big ladles. Like seriously, like my mom's like cooking spoon. Okay, that might be the fattest thing I've ever said. Okay, good. Are we good? One more. Let's just talk about this one really, really quick, okay? We already have the graph. I don't think we need to do the ordered pair. Do we need to do this, or are you guys okay with this? But, I mean, it's basically using these points, and we just do the same thing over there. Okay, are we okay, though? We're okay? Let's talk about the graph, and then we're going to be done. Fair? All right, tell me what you notice. Oh, first of all, this is absolute value. Absolute value. Absolute what? Value. What does value start with? It makes a V. Absolute value. Oh. Yeah, you're welcome. Okay, so here we go. Here's your parent graph. Absolute value is X. We'll talk about more about absolute value later. Okay, basically it's always positive. That's why everything is above the line. Okay? Absolute value is going to be like that. If it's negative absolute value, if we put a negative on the front, which way do you think it flips? Down. Because it doesn't matter. Everything's going to come out negative. Okay? All right, here we go. Tell me about it. Hey, stick with me, guys. I'm almost done. Stick with me. I'm almost finished. It's a lot, I know. Last one. Give me 2 more minutes. Tell me what you got. Function. What else? Decreasing and increasing. Decreasing slash increasing. What else? Oh, wait a minute. A bunch of dots. Hold on. Are the dots connected? So what is it? This one is discrete. Discrete. This one is discrete. You guys good on this? Function, everything's good? Okay. So today what I'm going to do is we're going to take a little break here. I'm going to give you guys till lunch because we don't have very much time left. When we come back from lunch, I do have your assignment for you. Okay. If you have any questions, let me know. Share it with your friends. Click the link below. All that good stuff. Okay. All right. You guys are good.